Let's look at another example of finding the order of a point on an elliptic curve. We're going to use the same elliptic curve as in the previous video, y squared equals x cubed minus 219x plus 1654. This time I want to find the order of the point 1124. Now, as I mentioned in the previous video, the formula for the third point of intersection, x3 equals m squared minus a minus x1 minus x2, is a little bit simpler in this special equation because there's no x squared term, so a equals 0. So we're going to keep using this formula, m squared minus x1 minus x2. Now we have to start by finding 2q, which will be q plus itself. To find that, we need to find the tangent line to the graphic q, and we'll use implicit differentiation, just as we did before. So we can use the same formula as before, which was that dy dx is equal to 3x squared minus 219 over 2y. I derived that in the previous video. And then we can substitute 1124 into that. So the slope of this tangent line is going to be 3 times 11 squared minus 219 over twice 24. And if you simplify that, let's see what we get. Looks like 144 over 48, which is 3. So the slope of this tangent line is 3. So an equation for the tangent line is going to be y minus 24 equals 3 times x minus 11. So y minus 24 is 3x minus 33. So y equals 3x minus 9. So here's the slope. Here's the equation for the tangent line. Now applying this formula, we can get x3, which will be the coordinate of this point of intersection. It'll be the slope squared minus 11 again, because I'm trying to add q plus q. So that's 9 minus 22, or negative 13. The y-coordinate of the point of intersection I get by plugging x3 into the tangent line. So that's 3 times negative 13 minus 9, which is equal to negative 48. So this point of intersection here is negative 13, negative 48. And then I reflect that across the y-axis to get 2q. So 2q is going to equal negative 13, positive 48. So 2q is negative 13, positive 48. Next, let's find 3q. Q is the same as q plus 2q, which is going to be 1124 plus negative 13, 48. So first of all, we can find the slope. 48 minus 24 divided by negative 13 minus 11 is 24 over negative 24, or negative 1. So the equation for the tangent line I can use either of the 2 points. Y minus 24 equals negative 1 times x minus 11, which is negative x plus 11. So adding 24 to both sides, I see the equation for the line through q and 2q is negative x plus 35. Applying this formula, we get the x coordinate of the third point of intersection, which is n squared, negative 1 squared, minus the first x coordinate minus the second x coordinate, which is 1 minus 11 plus 13, or 3. I can get the y coordinate of the point of intersection by taking that 3, substituting it into the equation of the tangent line. So it'll be negative 3 plus 35, which is 32. And then I reflect across the x-axis to get negative 32. So 3 negative 32 is equal to q plus 2q. So let me record that here. So the order's got to be something bigger than 3. I haven't gotten to the point at infinity yet. So let's keep going. 4q is going to be q plus 3q, which is 1124 plus 3 negative 32. Let's continue as before. The slope is negative 32 minus 24 divided by 3 minus 11, which is equal to 7. So the equation for the tangent line will be y minus 24 equals 7 times x minus 11, which is 7x minus 77. So adding 24 to both sides, I get that y is equal to 7x minus 53. Now to get x3, it's going to be m squared minus x1 minus x2, which is 7 squared minus 11 minus 3, which is equal to 35. To get the y coordinate of the point of intersection, I plug that 35 into here. So 7 times 35 minus 53, which is 192. And then I reflect across the x-axis to get y3 is negative 192. So my point is 35, negative 192. So let me record that over here for 4q. So at this point, you should pause the video and work ahead. Find 5q, 6q, 7q, 8q, 9q, and keep going. Eventually, you should get the point at infinity. So I'm going to assume that you're pausing the video now, and then when you come back, I'll write the answers on the board. For 5q, you should have gotten 35, positive 192. For 6q, you get 332. For 7q, negative 13, negative 48. For 8q, 11, negative 24. And then finally for 9q is going to be q plus 8q, and notice that those 2 points lie on the same vertical line. So that means that 9q is the point at infinity, which we call 0, or call O. Therefore, the order of the point 1124 is 9. Now, an interesting fact is that if you look at all the points of finite order on this curve, they're in this list. So if you look at all the points of finite order, they do form a group, and that group is isomorphic to Z9, and the point 1124 is a generator. We'll learn more about that when we study the Navier-Lutz theorem.